Hello, hi. I am Omshi Krishna. My topic is about drift velocity. Telling about drift velocity, first we will see what is meant by drift velocity. Drift velocity is the average velocity with which electrons drift in the presence of electric field. It's the drift velocity that contributes to the electric current in contrast. Thermal velocity causes random motion resulting in collisions with metal ions. Here V equals to I by NQA, where V equals to drift velocity. That means drift velocity equals to flow of current by number of electrons into charge of electrons into area of cross section of wire. Here drift velocity is proportional to current. In the resistive material it is also proportional to the magnitude of an external electric field. Thus Ohm's law can be explained in terms of drift velocity. The last most elementary expression is where U equals to drift velocity, nu is the material's electron mobility and E is electric field. In the MK system the quantities units are m by s. When a potential difference is applied across the conductor, free electrons gain velocity in the direction opposite to the electric field between successive collisions. As a result, there is a definite small drift velocity of electrons which is superimposed on the random motion of free electrons. Due to this drift velocity, there is net flow of electrons opposite to the direction of the field. SI unit of drift velocity is m by s. It is also measured in m square by v by into s. The drift velocity of electron per unit electric field applied is mobility of electron. Its dimensional formula is m1 t2a. Now we can see how drift velocity is measured. We can calculate the drift velocity using the equation I equals to NQA Vd. The current I equals to 20, A is given and Q equals to minus 1.60 into 10 to the power of minus 19. C is the charge of electron. We can calculate the area of cross section of the wire using the formula A equals to pi r square, where r is one of the given diameter 2.053 mm. Now we see what is the relation between drift velocity and electric current. Mobility is always a positive quantity and depends on the nature of the charge carrier. The drift velocity of an electron is very small, usually in terms of 10 to the power of minus 3 m so minus 1. Hence at this velocity it will take approximate 17 minutes for electron to pass through a conductor of 1 meter. But it's surprising that we can turn on electronic appliances in our home at lightning speeds with a flick of a switch. This is because of an electric current is not established with the drift velocity but with the speed of light. As soon as the electric field is established, the current starting flowing inside the conductor at the speed of light and not at the speed at which electrons are drifting. Hence there are negligible small delay between the input output turning of electric bulb. Relation between drift velocity and current density. We can define current density as total amount of current passing through the unit cross-sectional conductor in unit time from drift velocity. We know the formula of drift velocity as I equals to NA VQ, J equals to I by A equals to NVQ, where J is the current density measured in amperes per square meter, V is the drift velocity of electrons. Thus we can say that drift velocity of electron and its current density is directly proportional to each other. Also, when electric current field intensity increases, the drift velocity increases and the current flowing through the conductor also increases. Vd equals to drift velocity of free electrons, E equals to magnitude of charge of an electron, M equals to mass of electron, E bar equals to external electric field, T equals to average relaxation time. Now we go about mobility. Electron mobility is defined as the drift velocity per unit electric field, that is nu equals to Vd by E. Its unit is m square by volt second. That is Ohm's law can be explained in terms of drift velocity as Vd equals to nu E. These quantities SI units is ms, m by s. It is also measured in m square by v into s. The magnitude of charge drift velocity per unit electric field applied is specified as the mobility of the charge carrier responsible for current. That is nu equals to drift velocity by electric field. that is nu equals to Vd by E. Nu equals to mobility of electron, nu equals to E by m. SI unit of mobility is nu. The important note of both drift velocity is the current flowing in a conductor is directly proportional to the drift velocity of electron. Unless an electric field is provided to the conductor, the electrons inside it move at random velocities and in random direction. Drift velocity is directly proportional to the current and inversely proportional to r square. When an electric field is applied across the conductor, the electrons shift towards the high potential end of the wire. Here, drift velocity does not depend on cross-sectional area or the diameter of any conductor. For the same potential difference here with V across the conductor, an increase in the cross-sectional area decreases in resistance or equals to no, and also increasing the current I equal V by R. From the diagram we see that E and the parts clearly. Look at the diagram. Thank you for giving this opportunity to explain about drift velocity. For next time I will better give than this time. Thank you.